Welcome to another draft physics presentation video. Mostly. A little bit of lag maybe. But anyway, mostly live-ish when I'm making it. I'm alive. But anyway, so sort of a Ken Wheeler video, but I think I'm just going to try to contrast the two ideas of the fundamental mechanisms of the universe. And so maybe just on trigger words, I will go to the drawings and try to illustrate the difference between, in my opinion, a rational theory and one that's just completely made out of verbiage, just jargon. Yeah. He did a video on magnetism. It was just all jargon, just hyperboloid, counter space, Poincaré, blah blah blah, something blah 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 blah, but convey absolutely no mechanism, no understanding of mechanism, nothing, just nothing.
The countless incompetencies, within physics, which is purely atomistic by its very nature. I call it
Okay, atomistic by its very nature. So he's arguing that somehow it's, I don't even know what that argument means actually, so I guess I shouldn't say anything about it. Atomistic in by its very nature, like somehow scientists are atomistic by nature. Maybe it does make sense that physics is atomistic by nature, because the subject is physics actually. It's physical things, and physical things have to be made of something, and so that's sort of the reason I think they say it that way. But anyway, whatever. I mean, this idea of using atomism as a negative word when you're always going to have to sort of concede the existence of something called atoms. I mean, it's sort of proven that there's atoms.
Cult of bumping particles.
Okay, cult of bumping particles. So here we have Einstein's bent space, no particles involved. We have quantum mechanics, which essentially has reduced everything to some sort of probabilistic wave function, and a Heisenberg concept that whatever the quantity is, it doesn't have a place in space or time, and that somehow it has to contact something else to actually become a something. So it doesn't sound exactly like a particle. And clearly particle physics is full of things that are virtual in nature and not time dependent, and it doesn't sound very particle-y. So again, and the fundamental one is the Einstein example, for example. I mean, clearly not a particle theory at all.
The one thing that it rests upon, by their own definition, is the explanation of light, and their immense confusion over something so incredibly simple.
Right. I would argue that it is incredibly simple. So it's clearly something that we have enough evidence to say certain things about. It's an indestructible thing, the energy of it, that clearly it is a consistent quanta, and the only way you can play with its substance is to create more of it or less of it. But it itself is always quantizable in terms of energy in and energy out, clearly measurable as clumps of something. So, that's the only rational place to start. Now, are you suggesting something else?
As wave-particle duality, as they love to put it.
Okay, right. I don't know if they love to do any of that stuff. They're stuck with a dilemma, because there are experiments that indicate that the photon is incredibly corpuscular, like so corpuscular you could call it a little meteor. And then there's experiments that indicate something went wrong with the meteor theory, because they just haven't had enough imagination to turn it into a meteor, make it into something purely kinetic, which is in his video here. That's why it's an interesting phrase he's using. Kinematic is pretty much a particle theory, so it's kind of strange that he's got it in the title. But anyway, we'll play a little bit more.
to talk endlessly about the double slit experiment. Now, I have a video from some time ago. I could recreate it if I have to. Or actually take a laser and point it at a needle. Just to
Yes, right. That's been done by billions of other people, by the way. It's not something you did uniquely. And it doesn't prove a theory of cause. We already know the effect. Everybody's aware of the effect. The argument is about cause and why do photons in special circumstances, and only special circumstances, behave in this strange way where they seem to be affected by forces rather than their common property of just going in straight lines until they hit a material substance. Now, I'm arguing that in those experiments the photons are hitting a material substance, an electron. Alright, so let's just go to the drawing a little bit, and I'm just going to throw some of his magnetism in here just because it's it's the only part that he's a little bit clear on. I mean, where he gives you some indication of how he would draw his universe, but he doesn't even attempt to give you a drawing of his universe, and I think you sort of need that. So here's the most simple drawing I can give of my description of the universe. And it's made of two things, the indestructible forces and the sometimes destructible little bits of matter. Now I would argue that these protons and electrons are the key players, and in the force there's something I call now an electron force and a proton force. And you can identify them as having two significantly different properties. I'm just drawing them as red and black just to indicate they're polarized different, they're shaped different, there's something different about them, and this is the only difference they have. Otherwise they're the same, except for this one difference. And this one difference means that when the black hits the black matter, black force hits black matter, it reflects. When red force hits red matter, it reflects. And the opposite is true when red matter hits black matter. When red force hits black matter, it is ejected perpendicularly to the direction the force was traveling, and likewise when black force hits red matter, it is ejected perpendicularly to its momentum. And those little facts create an idea where you can have regulated pressure between these matter bits. That is, you can have regulations of attraction and repulsion. Attraction when there's no force trapped because neither force can bounce back and forth, and high pressure when two common matter bits have their common force bit trapped between them. That force bit will bounce back and forth and can create, depending on distance, more or less pressure. So there's lots of pressure mediation happening in this mechanism. It's highly capable of mediating, okay, regulating, changing states of pressure, and that those states of pressure actually do create the difference between, if the electrons are close together, if force is emitted, it might be in the form of an X-ray. If the electrons are further apart and force is emitted, the force is likely to be in the form of a radio wave or microwaves or some lower frequency radiation. And that's how radiation is created and destroyed inside of matter, is it gets trapped between these forces. Now the whole electromagnetic spectrum is always black force, and the force that might be involved in something like what they call positrons or something like that is probably the red force. But it's so difficult to move protons that we don't see that force used commonly because it can't do any can't significantly change the atomic structure, because you have to move electrons they're on the outside of the atoms, they're the more hittable element of the atom, and so they're more changeable. You can affect them easier. So the red force seems more irrelevant to us just because it can't affect an atom as readily as black force, because black force can move the electrons. So that's the simple brief. And with that mechanism you create the positive and negative charge. With that mechanism you create the poles of magnetic attraction and repulsion. Clearly the proton and the electron in a sense are just the key elements in what could be called the monopoles of charge. Alright, now Ken Wheeler's description has some sort of ether okay, that surrounds everything and is everything. And this ether swirls and moves in perturbations of some kind, and these perturbations somehow affect other perturbations in something else and create attraction and repulsion. But it's sort of a vague notion, and I would argue that this description in no way can be detected by any experiments that have been done. So if there's all this movement around a magnet, and this movement is actually strong enough to create currents that move things together or push things apart, then why can't we just put a few electrons in here, or put a little tiny piece of atoms and watch the atoms being moved around the magnet? Why can't we detect the motion that you say exists? And there's no way to detect any of it. It can't be detected. It can't ever be seen as motion. So there's no evidence that anything is moving around magnets. It's essentially just it's a convenient notion to make the magnet a player, but it doesn't create any of the energy. But they have to make it energetic because obviously the force that's coming off of a magnet seems energetic. But that's because they don't understand it's not coming from the magnet. So they have to make this energetic because they have to explain why force actually comes out of it. Because they're not understanding a very simple conception of what a magnet's doing, which is that a magnet's just a filter, and the force comes from the outside universe, and all that happens is this electron and proton force is filtered by a magnet. So all the force that comes in this way, red, into a black, ends up coming out the red end. So the force comes in this way, it'll be, if it's a piece of black, electron force comes in this way, it'll end up coming out some direction this way. If a proton bit of force comes in this way, it'll come out somewhere in this way, and vice versa, but that's sort of irrelevant. If a black force goes into a black, it's just going to reflect. So that won't be anything of consequence. That will be gravity, actually. This is essentially gravity here. That's always surrounding everything all the time. And, as illustrated in the first drawing, this is the simplest vision of the universe. Everything is surrounded by this pressure that's in the universe. And that's what moves planets into suns and all the rest of it. But on a small scale, this is what it's doing. On the big scale, it's doing the same thing, essentially. It's just capturing force. That's all that matter really does. So anyway, so that with this simple diagram, as I pointed out, the black force always reflects off black things, and the red force always reflects off red things. So clearly, when the magnets are arranged in the same polarization, all the black will reflect, all the red will reflect, and you'll have repulsion. When it's in the inverse, the opposite will happen. All the black force will leak out and the red, and all the red force will leak out the black, so there'll be zero pressure, and the magnets will attract because the external pressure will force them together. In terms of how the magnet is arranged, and the idea that you can cut the magnet anywhere you want to and create a new magnet, it's simply because of the arrangement of the pluses and minuses are staggered by the magnets themselves. They're attracted to each other's opposites. So the red end of two magnets are sticking together. The red end is going to want to stick to the black end, and then the black end will be above it. And so they're always staggered. And so when you break a magnet, you always create the same stagger, which will mean that only red will be pointing up this way and only blacks will be pointing up this way. So you're always breaking it on the same polarization line. So you're always creating a pole. Every time you break it, you create two poles. You can't avoid that. And so that's why you can break a magnet anywhere and create two new magnets, because you just create two new south and north poles, respectively. But a simple diagram, little tiny magnets inside, so you just break them and blah blah blah. But the force goes in one way and goes out. It's just so simple. And so, nice mechanical model. No woo involved, nothing complex. I kind of attempted to do a Ken Wheeler description of a starting point, but I can't start with anything. All he has is vague things called space and counter space and something called a loss of inertia and a magnitude. How do I, no, can't draw any of that. So we'll see if we get anywhere.
Shaft of the needle, which of course is nothing other than a simple rod. You don't need a double slit experiment to replicate the results of the double slit experiment.
Okay, so he says he replicated them, but he really didn't. So, I mean, I don't know if I really want to argue the double slit experiment again, but we'll do a real quick, I'll try to do a real quick version. Oh, sorry, I didn't have the video on, so it's good to know that. There's two patterns in single slit and double slit. And the two patterns, essentially, you have something that looks very bar-y, plain bars going across. So this would be a typical single slit experiment. The real double slit experiment, okay, and this wasn't really covered by Young, but it's what was found to be the big difference between the double slit and the single slit is the fact that the double slit has essentially two patterns built into it. So the pattern is made of something that has two kinds of on-offs. The little individual on-offs, and then a built into it on-off. So it has this bars, and it also has these bigger bars in a sense of an on and an on and an on. So there's two patterns in the double slit, and a needle won't create that. A needle will create this single slit pattern. It doesn't create this double slit pattern. So it is a distinction. Worth noting, I suppose. Where was I? So in essence, the point being made is that the double slit experiment has the center of impediment is very important to the double slit. So this is we'll call that the center, and then this is your opening here, and this is your opening here. And so a needle is duplicating the center impediment, which is essentially a single slit in reverse, right? I mean, it's not that complicated in the sense that it's basically just a single opening. It's two sides, side A and side B, and a needle just has the sides inverted, but it's still two sides, one side over here and one side over here, and both sides essentially diffract the light like this to create a pattern. And in the single slit, the same thing is happening. Both sides diffract light, bend it in both directions. But if this slit width is narrow enough, then you have four sides. You have this side, this side, this side, and this side. So you have four surfaces. So that's really the difference. You have to have a very small double slit experiment to get this pattern. If you have a very wide double slit, you won't get this pattern because the two sides will become too irrelevant. Too little light will be hitting them, and they won't create any effect. And their effect will be too off the regular pattern. They'll just blur the primary pattern. They have to essentially be in phase with the primary pattern for you to get a very clear, to get this pattern to be very clear. Essentially the slit width, the width of the openings has to be in it has to have the same phase. It has to be a multiple of, like this is a 2 and this is a 4 and this is a 2. It has to somehow be a multiple of the diameter of the impediment. They have to be in the right proportions to get a clearer double slit pattern. Okay. I mean, I'm really simplifying things, but I think you can follow along. I hope you can. That's all I can do is hope.
you have constructive, destructive banding interference. You get the same thing from shooting a single point source, which people think that laser light is coherent, which it is ultimately attributionally, but as a point source.
Again, it is attributionally. So he keeps playing with these words coherent. Now we already know lasers aren't perfectly coherent, which means parallel. So it'd be nice if people just used, instead of using a word like coherent that has multiple meanings in regular life, they probably should use the more descriptive sentence. Because without the sentence, it's like I say, I love you. That could mean I have a boner, okay? Or it could mean, oh, you're really a nice guy and I hope you have a nice life. I mean, you know, but nothing personal. You know, it's just no good using words that don't say enough. And the word coherent really doesn't say enough to most people. Now, it might have a technical scientific definition, but everybody we're talking to doesn't have all those definitions. So saying coherent and then collated, and there's another one, collinated. Lots of different words, and so I think it just creates confusion. But the idea is light rays can be very parallel as they leave a source, or like a light bulb, they can be radial. And so they're not at all parallel, the different rays. And that's really the difference. So when somebody says coherent, they're really just trying to say the light is compacted and all going the same way, condensed into a small amount of space and all traveling parallel-ish.
Illumination, that you get the exact same interference pattern banding from shooting a laser directly at a needle.
Okay, so it's not exactly the same pattern. It's the same pattern as the single slit, not the double slit. So again, you're being a little bit deceptive.
And the resultant pattern that's left on a white sheet of paper after doing that. But the notion that light is a particle or a wave-particle duality.
Okay, so he doesn't like either word, but he likes the word perturbation, which sounds pretty wavy. But the problem with this is that this is one thing we could draw about his theory, is, you know, some understanding of the difference. Okay, so we need a blank piece of paper, I think. Or maybe we have space on his page, you know, his hyperboloid. I mean, this is the torus. Well, I didn't have to have the drawing up to do that, Gary. So this is his torus. It's up here spinning this way. And these are the hyperboloid of the, whatever he calls it, the donut thing. And it's all, these lines don't really go straight down. They curve around. So they have motion in them, and they're all energetic somehow. And the idea is that if you have two of these spinning things, and they're both spinning the same way, then they'll move away from each other, because this one's pushing this way and this one's pushing this way, so they'll push against each other. But if they're moving opposite directions, then somehow this one going this way and this one going this way, they'll pull into each other, because this one's pulling away the same direction as this one's pulling away, creating low pressure. But that theory, just, you know, intuitively, I think you can figure out that magnets are incredibly attractive to each other, and they attract right through that field. And so if you actually did push two things that were spinning the opposite directions into each other, they'll actually repel. They won't stick together. They'll move towards each other, but they can't combine. So it doesn't really explain why magnets are so attracted. I mean, this spinning idea creates a very weak force, not a really strong force. And magnets are a really strong force. Alright, so I didn't want to do magnetism. I was doing, so where were we? We were the needle, wave, okay, wave particle. So obviously, I think you can understand particles as being capable of duplicating what we call a wave. So all I'd have to do is make enough particles all coming out at the same time, and you would see that as a wave. You could kind of understand that, oh yeah, there's a lot of particles here, no particles, a lot of particles, no particles, a lot of particles, no particles. So it can have the appearance of a wave. And certainly the frequency thing is just anything with a frequency is going to have a kind of tendency to be called a wave when there's enough of it. But the trick with light is that it does do this particle thing in the sense that it clearly moves in rays. Alright, I mean it's clearly very narrow, collated, what's the word you use for the laser light? I mean it's a ray of light. So it doesn't really behave like a traditional wave in any kind of substance. So all waves in mediums, so water or even vibrations in steel, any kind of medium, when it transmits a wave, it transmits it by spreading it. So it converts the impulse, whatever impulse there is, it spreads it in all directions. It really doesn't do this just dot 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 photon kind of thing. So it's very dissimilar to a photon. And so clearly comparing water waves to photons, there's a clear disconnect mechanically, because a photon isn't waving in any sense. It's not spreading like a wave, and it's not creating energy in all kinds of different places when it hits. It creates energy in one place, and all the energy goes there. So none is wasted anywhere else. The photon hits a photon corpuscle. It doesn't lose any of its energy ever. You can never have a weak or a strong photon technically. The element that makes up the photon is never strong or weak. It's always one quanta of energy. Ergo the name quantum mechanics. That's why quantum mechanics is supposed to be about quanta of energy. But it's gone. It's left the building. So it's not really doing that anymore. So I'm just saying Ken doesn't give us an explanation of his field, perturbation, and how it functions, beyond saying something like it's a coaxial cable. I mean, I don't know. That does it for you. It doesn't do it for me. It doesn't give me any clue what he's talking about. Any clue at all. It seems like a very elaborate piece of hardware to carry something so simple as a photon. I shouldn't need a coaxial cable to move a photon from point A to point B.
As the idiot Einstein and the cult of quantum has reified it as, this is completely absurd. A wave does not even exist. A wave is not a thing, rather what a thing.
Well, let's understand Einstein wasn't too happy with quantum mechanics. So again, he doesn't want to talk about waves. He just wants to talk about perturbations. And what all of us should be talking about is frequency, because that's what it is. It's wavelength, period, and frequency. Now, wavelength is a little bit tricky a word, but we all know that if I shot bullets at a rate, we could measure the wavelength between the bullets. So the word shouldn't make you think that wavelength always has to be a wave. It's just the length of the period. So it should be called period length or frequency length. But unfortunately, people like Maxwell were the ones who got to choose what words we use. So the funny irony is that the very guy who thinks Maxwell had it right, he's the one that basically created the word wavelength.
It does. Light is a coaxial circuit, necessitatively so launching.
Okay, so he said it, right? So I wasn't lying when I said that. It's a coaxial circuit. So, I mean, I'll just draw what I think any rational person's understanding of coaxial, especially in the world of coaxial cable used for cable transmission. I mean, that's how everybody understands the word. So, I mean, I don't know how, you know, he hasn't drawn this thing called a coaxial cable. But, I mean, the idea is the cable is that it has a shielding, and then it has a conductor in the middle and an insulator between. And so it's basically two wires. One is a big wraparound thin wire, and one's a little core wire. And one carries either positive or negative at any one time. One's positive and one's negative, or one's negative and one's positive. It just carries an electric circuit, a current. And so we know the current's either moving that way through the wire, or it's moving this way through the conductor. But it's through the shield. But it's doing one of those two things. But how does this explain light? There's no element of light that goes back to its source and says, it doesn't send postcards back to mom. If mom said, "Go west, young man," the photon goes west. It doesn't go back and kiss mom and then come back again, and it doesn't do any of that. It just goes west. It doesn't ever connect to the thing that it originated from. There's no circuit. There isn't any. There's one path from here to A to B, and there's just nothing sent back. I can't imagine what that would be. So I don't understand how saying coaxial cable is at all illustrative or useful as a metaphor or analogy. So I don't know why he's doing it. I don't know why people find that interesting or useful. I can't make any sense of it at all.
Just pulse perturbations.
Right, so it's a pulse perturbation. So it's like a clump, a pulse perturbation. And he's just saying it perturbates, and then it goes, and then perturbates, and then it goes, and then perturbates. So it's some sort of thing perturbating. Like a little Pac-Man maybe. It's going like this. But can't that be a metaphor for a clump? A little solid clump that is moving? How is a perturbation move differently? That would be the question. How does a perturbation move differently than a rock? So if I had a rock and a perturbation and I threw them, how would I know that the perturbation is doing something different than the rock is doing? What would be the giveaway feature that the perturbation has that the rock doesn't have? Because I would argue, even though they talk about electromagnetic fields and stuff, photons can't be detected because they perturbated the field. You can't listen to the field or hold the edge of the trampoline field, and you can feel the photon go through. That can't happen. You can never detect a photon except by having it crash into something. It has to end its perturbating. You can't in any way detect it while it's perturbating. It has to hit something, period. Or there's no way to detect that a perturbator went by. Perturbators are invisible until they stop perturbating. And the same thing would be true of a very small rock. If I make the rock small enough, you can't detect it because you can't bounce anything off of it to see it. So how would you know the difference between a perturbation and a rock? How do you tell the difference? How do you know there's a difference? How do you know it's a perturbation and not a rock? Besides saying, I think so. No, I think it's perturbation. Sure. I mean, is there some other reason besides you just like the word perturbation more than the word rock? Because I can't figure out how you know the difference, because I can't imagine a single experiment that gives it away.
With the dielectric line of the field perturbation,
okay, so the dielectric line, whatever that is, so it's a coaxial cable running on the dielectric line. Now I'm supposed to draw that somehow. So there's some kind of dielectric lines, so maybe it's like rope theory, gates, and the cables are run on those lines, and then they're juiced, but it still doesn't make any sense. But the photons don't go back. There's no message sent home.
You can say conventionally propagation, but nothing emits light, nor does light have a speed.
Okay, light doesn't have a speed. I mean, so these people who defend can. I mean, you think that's a reasonable thing to say? You really do. You think with all the evidence we have of how consistent the speed of light is as a measuring tool, it measures tons of things incredibly accurately, and it can only do that because its speed is consistent. So why would we argue that it doesn't have a speed, this perturbation or this rock? I mean, is that a possible starting point of a axiom Like Ken's sure it doesn't have a speed, when all indications are it does, a very consistent speed.
Sort of rate of induction.
Okay, so is there much point in saying that the rate of induction is not a speed? So all you're saying is it has a variable speed. You're not saying it doesn't have a speed. You're saying it has a variable speed based on whether it's traveling through jello or molasses or brick. So depending on what it's traveling through, it moves at a different rate. Now I would argue that that's not true, that the photon itself is still traveling the same speed. It's just, it has to, when it goes through a medium, it has to travel the cracks inside the medium. The medium has a geometry in it, and it has to travel that geometry. And that geometry makes it go in non-straight directions. It doesn't just fly through the medium. It doesn't bore through it. It has to travel the geometry of the atomic structure. So it takes longer because it has to travel longer. I think that's a perfectly reasonable explanation for why it appears that light moves slower in some substances. I think it's a perfectly reasonable explanation.
And of course results in transverse electrical magnetic to the pulse perturbation of the dielectric. Whether that
Okay, so so you fair coppers, you people who love Ken, you think that's a way to talk physics. That jargon means something to you. It speaks to you. And that's like Charlie Brown's mother going, and that's not English. It's not a communication. I'm sure you can't write those words down on a piece of paper and define them. I mean, why do you let him? Why do you keep encouraging him to up his vernacular into all this gobbledygook? Why don't you oblige him to talk in some sort of rational language? I mean, that was just such crap, mush, word vomit.
is linear circular polarization, but light is certainly not a particle.
So again, circular polarization, we know light comes in all kinds of polarizations, and the idea, see, somebody can say the word circular polarization. Oh, I don't have the video on. Sorry about that. My mistake. It's not a very good drawing to leave it on. Sorry, no rudeness intended to the video maker. The word circular polarization is another, it's just dangerous language because people get this idea that polarization is moving this way, or it just basically, in my opinion, means the polarization is so tight that you can't define which way it is. The polarization is so fine, that means it's almost non-existent. The light is so coherent in that each perturbation, to use Ken's words, is so well lined up that there's no polarization. So it's called circular because it can be anything, so to speak. It can go through any filter because it doesn't have a polarization. Essentially. Something like that. I would argue is a viable explanation for the concept of circular polarization, but there's no such thing as really circular. It can't be polarized circularly. It has to be polarized in a dimensional line. That's polarization is being polarized in a dimensional line. It's not, can't really be circular. And so circular is just used for the concept of no line. Okay.
This pulse perturbation, or a string of beads, if you will, is a simple visual analogy.
Okay, a string of beads is like a string of particles, isn't it? So he's conceding that, oh, maybe that particle idea isn't so wacky. So, you got to catch these. I mean, that might be a little point, but isn't that sort of a Freudian slip on Ken's part? It's like a string of beads. Exactly. That's how it behaves, like a string of beads, like a string of clumps of energy.
In your head, is where the notion of the photon came from. Obviously, so the smaller the space, the higher the capacitance.
Okay, the smaller the space, the higher the capacitance, which is not obvious at all, actually. I mean, capacitors need a lot of space, so to speak, a lot of real estate to create capacitance. You get more capacitance by making, if this piece of paper had charge on it, I make it as a capacitor, okay, I make it bigger by making the space bigger. So the bigger the paper, the bigger the capacitance. So to say the smaller the space, the higher the capacitance isn't true at all. The closer you can get the two things to each other, the higher the voltage. If you have a good insulator, then you can create more total energy. But because the further away they are, energy is pushing things together. That gains you increase in the voltage. But space is to say that smaller spaces hold more energy. Everybody should kind of know that that can't be true, because little batteries suck, big batteries cool. Everybody kind of knows that.
Example being in the electromagnetic spectrum. The really, really dangerous crap is the electromagnetism, not this extreme.
The electromagnetism is the dangerous crap. Now, we sort of know that's, I don't know if that's at all true, but it's not exactly the same manifestation of force, in the sense that it is this filtered force, and clearly lots of the stuff inside of us is magnetic, polarizable. And so with enough magnetism, yeah, you'll start turning all of our blood cells and doing all kinds of weird things. But it takes a lot of magnetism. I mean, Tesla amounts of electric bill. Tesla had a whole power plant essentially devoted to his purposes. He needed so much electricity power to do his experiments.
Extremely huge in volume and frequency, which would be lower frequency, but incredibly, incredibly, incredibly small. The stuff that will actually break your body's cells apart and kill you forthwith is the smallest spatial footprint of electromagnetism that there is. We're talking upwards of gamma.
All right, well, it's not electromagnetism. So again, he's using vernacular. It's just incorrect. Okay, so she means electromagnetic spectrum photons. It's not electromagnetism. And yes, the high-frequency photons are like machine gun bullets, and you can knock things over with a machine gun that you can't knock over with a pistol. Fact. It will, hitting things repeatedly in shorter periods of time between the impacts. Punching, for example, you punch somebody twice really fast, you can knock them over easier than if you punch them once and wait a while and then punch them again. It's like one of those clown balloon things that you used to punch, kids use. You can knock it over if you hit it twice hard. You hit it once and then come back and then hit it again, you can't knock it as far over.
Gamma and beyond gamma. But this notion of a wave-particle duality is the most laughable bullshit that I've actually come across. And
well, I think there's a ton of stuff that I find laughable. Multiverses, that's pretty laughable. Dark energy and dark matter is pretty laughable. Bent space, in my opinion, is hilariously silly. So there's lots of laughable shit. But you're not getting to the fundamental point. You said photons are like a string of beads. So physics isn't wrong. You haven't explained how that's laughable. Your analogy is exactly how physics is pretty much playing with it. Except they're not saying it's beads either. They're just kind of saying it's waves, or it's corpuscle of pressure, or it's something. But I'm just saying, this is almost a semantics argument when you're sort of conceding it's like a string of beads.
Examining the stupidity superficially from, Platonic and retroductive perspective, where we actually take a logical examination of what light is.
So again, logical, in my opinion, would be paying attention to evidence. And you don't seem to cite any evidence at all, ever. I never hear you cite an experiment that demonstrates something. I just don't see you doing that.
Wave is not a thing. It does not exist. There's no such thing as a wave. There is something that is waving, but a wave.
There's something that is waving. So again, he's hung up on the medium being the important player. So even though he said string of beads, he really meant that there's either a lump in the oatmeal. There's oatmeal and then there's lumps in the oatmeal, or there's unlumps, like air bubbles in the oatmeal. So there's something different. And clearly, when physics talks about it, they're making that distinction. They're saying there's something called nothing, and then there's something called the photon. So there's a something in a field of nothing. They seem to be doing that. So I don't know what your objection exactly is made out of.
Wave is not a goddamn thing. There's no such goddamn thing as a wave. Excuse me.
So again, it's another thing with this speed thing. This seems like pathetically semantical. There's no such thing as a wave. We clearly understand the concept. The concept, especially in fluids or material things, we understand it's a migration of pressure through an atomic chemistry. The atoms change, they jiggle different, and that jiggle passes from one atom to the next atom to the next atom, and depending on the medium, that jiggle moves at a specific speed, the speed of sound, for example. And with light, it moves the speed of light, except, well, obviously I'm pointing out that light doesn't move as a wave, so it's not the same thing as sound at all. So again, I would agree, wave particle is stupid. It is particle. It's corpuscular theory. And the wave phenomenon is a byproduct of what happens when photons hit electrons. It's an illusion. It isn't. There is no wave property.
I'm like cussing, but I have to cuss.
I have to cuss. They're poopy heads. Whatever.
Hearing these idiot physicists, which are atomists and mathematicians.
Whatever. To call everybody else an idiot when your theory is so undefined, ambiguous, just a bunch of gobbledygook words, and here you are saying you've done something to be able to sit there and ridicule their thought process when at least they do provide a thought process. And they don't do, well, they do things where they sometimes say it's like a string of beads. I mean, you're providing nothing. I mean, I can't draw anything on the piece of paper because it doesn't make any sense. It's a coaxial cable strung across a lack of inertia with perturbations. What is that? I'm supposed to make something out of that in my fucking head? Oh, excuse me, I swore, but I mean, jeebus Christ. Could you be more incoherent? Unparalleled? I mean, you're all over the place. And it's all just jargon words all over the place.
Who believe they can quantify anything and everything.
Well, they can. That's the fucking fact. So you can claim they haven't quantified things, but they really have, okay? There's really specific, redundant, over and over experiments that really prove that there is he uses the word Planck. He understands Planck constants. He understands these are real things. So why is he pretending we can't quantify a lot of this stuff? Of course we can. It's just silly.
Quantifying something that does not exist.
And so again, everything doesn't exist. I mean, it's just so stupid. I mean, either the jello exists and the air bubbles are a vacuum in the jello and nothing in the something, or there's something in the nothing. But there's not a third alternative. Something in the nothing, or nothing in the something. What's the third alternative? Something in something, or nothing in nothing? I mean, come on. You gotta do better than this.
A wave is a connotation of something doing.
Connotation? It's a connotation now? What the hell? You're just making up sentences. Just random, willy-nilly. What kind of word popped in my head? Oh, dog do just popped into my head. It's a dog-doiation.
Something. It being in motion as implicitly defined.
Motion. I just thought of humping, you know. Humpiation. The photons humpiate, you know.
So a light cannot be a wave.
I agree that wave theory is silly because light is obviously ray theory. Obviously light is in the form of rays. There's always rays of light. It's always rays, little vectors of light. It's clearly rays. And it only does this, whatever the wave thing is, somehow when it encounters a tight opening between a material gap, that somehow the gap, all right, forces the ray to do something wacky. But they just make up these, like it makes little waves and Huygenses or something. They're just trying to explain it. Those explanations have absolutely no evidence defending them. They're just guesses. But, you know, it's sort of intuitive to point out that it appears as if the ray just bent and went to a new location because the photon is intact. So it appears kind of clearly that the ray comes in straight and somehow it's bent by the interaction and ends up going in one of those directions by a probabilistic scenario is the word I'm coming up with, but there's a better word for it. But by probabilistic cause, that's not what I'm looking for. Accounting, no. Well, anyway, there's a reason it moves, and they really don't have a specific reason. Alright, now I theorize that it's because there's electrons between all material bits, and the photons are hitting electrons, and the more electrons you hit, the more bending you do. But, you know, their theory isn't founded by any, there's no evidence for their interpretations of why the ray ends up somewhere. Their interpretations are completely without any evidence. And so they're just guesses. And I think they're pretty poor guesses.
Talking about the electromagnetic waving of the coaxial circuit of light is something else, but
the electromagnetic waving of the coaxial circuit. So he's allowed to use the word waving, okay, inside his coaxial circuit. So again, you people who think Ken is doing a marvelous job of explaining reality, that's a marvelous job. There's no waves, there's only waves in something, so there's what, a wave in the coaxial cable now. How does that provide an understanding? How do I draw that on a piece of paper?
certainly there are no particles involved.
So whatever, certainly there's no, except the ones that look like beads on a string.
The constructive and destructive interference that you would see shooting a laser light or a single very tiny light source at either the needle, as I proved, or the double slit experiment that they love to talk about endlessly. Oh, the duality of the double slit experiment.
Look, the history of the double slit experiment is entirely tainted, so you have right to mock it, but you're mocking it inaccurately. So let's understand. The Young experiment showed up, and they saw this interference pattern. And the funny part was they didn't recognize it as Newton's rings. Okay, it's exactly the same thing, you're just cutting off the ring part. Okay, but it's the same exact pattern that you get with a single aperture. I mean, Newton didn't bother making a square aperture to create only the bars. Right? He didn't bother doing that. He just took a round circle and created the ring pattern, the bars all the way around. But that's technically all it is. And the double slit is just demonstrating, when Young presented it, this thing called an interference pattern, where it's the same pattern Newton's rings is. It's not a different phenomenon, it's exactly the same phenomenon. And so that was the kind of the bastard start, is that this conversation about interference should have started with the single slit, not the double slit. It should have started with small aperture. And it should always start with small aperture. That's the source of this conversation, not the double slit.
There's no confusion there. You need to stop looking at light as either a particle or wave. What's happening is you've set up a spatial interference in which phase is introduced.
So phase is introduced, and that's what all of them believe too. So, where's the complication there? I obviously don't think phase has a single thing to do with it. Frequency does, but not phase. And the frequency only matters in the sense that when you hit electrons, the faster the bits are coming, the more likely the electron is to move more distance, and the more distance it moves, the different angle the new photon will be released at.
Phase and a spatial interference are one and the same thing, just as space is denotatively the resultant effect of divergent magnetism in creation, that you end up with an interference of the disturbance, which we call light.
The interference of the disturbance, which we call light. Interference of the disturbance, which we call light. I mean, so to you people, that just says, wow, oh yeah, I get that. That's like pumpkin turns into carriage. I get it. I mean, I don't mind if you're going to describe a pumpkin turning into a carriage, but see, I can understand that. I can visualize, okay, pumpkin, carriage. Yeah, same shape, basically. Okay, I can go for that. Little mice turn into little carriage people. Okay, I can do that. But I can't do what you're doing. So even the wackiest of fairy tales makes more sense to me than this. I can't make anything. I can't make any kind of head, tail, butt, toe. I can't make anything out of this.
And that disturbance is an interference pattern. That interference pattern is the light manifesting its perturbation through either around the single needle or the double slit. It doesn't make any difference. And when you have that interference...
Okay, it's interfering because it's perturbating around. It's perturbating around. And it has great magnetone. And it's inertia. Yeah, he's kind of Trumpy, right? We have great latitude.
So you have that phase. Then you actually have constructive and destructive interference. You'll actually see that on the wall with a white sheet of paper.
So again, I don't see how his little chain of beads, as he calls it, it's like a string of beads. So the string of beads goes into the double slit experiment, and I don't see how he's explaining any of it. How do the beads end up at all these different locations? Does he explain any of it? No. Nope. He doesn't use a wave theory. He doesn't use a cable theory. He just says something. It perturbates around it and banga banga banga. Doop de doop de doo. Wop wop wop. Happens.
It's ridiculous that something so simple confounds the minds of these idiots with
Okay, so again, we're idiots because we're confounded by your incomprehensibility. You have massive incomprehensibility, and we're confounded by it, and therefore we're fucking idiots. I mean, it's just... I mean, this stupid rag that we're to fault because we don't understand. When if I play this video to a high school class and then we test them on what they learned, do you really think they're not just going to end up sticking their pencils in their eye? That they're actually going to know how to do anything or understand anything after the experience? Of course, it perturbates around the needle. Well, it's just obvious. It perturbates through the disturbance and creates the pattern. Yeah, I can answer that on the test. What is light? It's a perturbation that goes... It perforates around the needle disturbance and goes coaxial, and then it beads, and then it... ba-ba-da-ba-ba-da. I'm going to get an A on the test.
There must be like 100 different books.
There probably is a lot more than that, I think. I think there's more books than 100. But anyway, go ahead.
about the double slit experiment. And
Okay, I don't know. Is there really books on it? I haven't seen the books on the double slit experiment, so it's an interesting theory that there's actual books on the one experiment, and I probably would find them hilarious. So maybe if somebody has a link to a online book devoted to the double slit experiment, it's probably worth reading because it's got to be funny as hell.
maybe 1,000 books and tens of thousands of articles about the dual nature. And this is the idiot Einstein.
So again, I don't think there's any books on that subject only. There's lots of people who have written about the fact that physics is stuck in this kind of silly position, where it's wearing girl panties and boy jeans and such, and it's it's a little embarrassing,
Einstein, the moronic idiot that he is. And by the way, Nikola Tesla called.
So Nikola Tesla is qualified to define Einstein as an idiot when Tesla spent the last 40 years of his life doing absolutely nothing of merit. Nothing. Zero. I mean, he fed pigeons, which is very nice.
Einstein a fuzzy-haired crackpot for a reason. Einstein's words were on wave-particle duality. He says, and neither one of them explains light on their own, but together they do.
Yes, he was making a concession speech because he got badgered into it. So he was just basically trying to say that, okay, if we have to say it, I'll say it. Yes, light looks like a corpuscle, but it behaves in some circumstances like a wave, and we'll have to accept that because we don't have a definitive answer one way or another. We don't have a picture of the little rocks, and we don't have a picture of it perturbating. So we'll have to just accept that we're stuck for now. But, I would have suggested Einstein not to make the concession. Because I don't think Einstein believed it. So you're calling Einstein an idiot because the physics community harassed him into addressing an issue he really didn't want to address. Because he'd rather just say, hey, we already proved it's a corpuscle. I got a fucking Nobel Prize for it, idiots. Remember when I got the Nobel Prize? Yeah, I got it for proving it's a corpuscle.
Fundamental thing that any of these idiot scientists have never fathomed is the most fundamental illegal law of nature or Mother Nature, and specifically it would be called natura.
Okay, so the illegal behavior of the banditos banzidos. We're going to speak in different languages now. It's a boot. I'll talk Canadian. How about that?
Not that anybody knows what the hell that means.
Yeah, that's right. Nobody gives a fuck. You just keep wearing it like some kind of badge. I know how to speak silly talk. I can speak ancient Egyptian. Ranky. Yeah. That's basically saying you have a very, very fat ass.
Is that there are no dualities in nature. There's only human stupidity.
And stupid arrogance, and stupid fat, and stupid fucking idiotic, incomprehensible tattoo art, and blibble and babble, and, nicky and knocky, and gibber and jabber, and silly and fucktarded. Fuck.
Confusion thereof, which would manifest a concept of a duality, but there are no dualities in nature. I mean, that's...
Yes, that's all I concede. And it's really not a duality, it's just a verbal game. That's all. They're just playing a game with the words. Okay? They're just modifying the word particle and modifying the word wave to their purposes when it's convenient. When it's convenient, it's a wavicle, and later it might be a parwave. Parwave. Anyway, enough. Alright, one more second.
It's the most absurd BS that could ever exist.
Yes, it is rather absurd, but your counter explanation is even more absurd. The string of beads moving through the coaxial cable, perturbating in the counter space. That's not any better. So anyway, it's worse, actually. Worse. It's worse. Everyone has to concede it's worse. Please, you have to concede it. It's the only rational thing to do. Alright, so that's enough. I think I've done my job here. So till the next time and such.